Okay. Last time we talked about bond order, right? Way back before we had our exam. Bond order, how is that defined again?
It's 1/2
Yep.
the number of bonding electrons. Wait, no, yeah.
Yep.
Minus is bonding.
Yep. Okay. If bond order increases, what does that mean about bond strength? Yep, generally. And if the opposite's true, right? If bond order decreases, bond strength should decrease. Okay. We can calculate these numbers. We can calculate the MO diagrams, but we want to rationalize what's happening in these systems. So we're going to move away from going from atomic basis sets to molecular basis sets, so molecular orbitals. And we're going to discuss the charge transfer interactions that happen there. We'll hopefully get some more intuition, so when we finally make it to periodic systems, we're going to understand everything at that point. Okay? So let's talk about charge transfer in MO theory. There's also strange things that can happen in solids that just cannot happen in molecules. In surfaces, it gets even weirder. So if we understand these things, it will help us to figure out why are these systems so unusual? Why do they differ? Like, why does it matter if I have one molecule of water versus a nearly infinite amount? Like, why does that change? So we can keep track of it that way. So the next section we're going to talk about is MO theory, specifically to charge transfer. Okay, we're going to consider molecules A and B that interact via their frontier molecular orbitals. You guys get what I mean when I say frontier molecular orbitals, or no? Okay. So the frontier molecular orbitals are, generally it falls into two categories. The highest occupied molecular orbital, or HOMO, and then lowest unoccupied MO, LUMOS. The reason for this is these tend to be where, like, these are unpopulated states, these are populated states. They're right at the cusp where stuff starts to be populated and unpopulated. This permits charge transfer to occur. It has impact on the bond order. This is really where most of the chemistry happens. Now, the frontier MOs, it doesn't just have to be the HOMO and the LUMO. It can be any of them within a certain energy window. That energy window changes based upon what's important. Okay? So if we look back at our system over here, where's our HOMO, where's our LUMO for HF? Yep, they count. Yep, this is our HOMO. Yep. However, if you really do anything with these, are you going to change any of the chemistry? No, nothing's going to really happen because they're being left alone. So you either got to pull electrons out of this bonding orbital, or you got to start dumping stuff into that LUMO to make a change happen.
How do we dump, like, how do we put the number on there?
That's a question for an organic chemist. Or if you think about it in terms of electrophile, nucleophile. That anti-bonding MO doesn't have any electrons, right? So, yep, you want a nucleophile to go after it, something with electrons to donate. That's how I think about it. I don't know how organic chemists think about it. I know Dr. Ogawa thinks that way. That's why I'm waiting for machine learning to happen or AI enough where it's like, okay, electrophile, nucleophile, boop. Like that's really what organic chemists are doing most of the time. They're just really, really good at it. Or they're willing to sit in the lab and boil stuff for 24 hours or longer, and I'm just flat out not going to do that. Or I get scared because I leave ovens on, and then I'm trying to go to bed at night, and then I go, shit, did I leave that oven on? And I drive into work and go, yep, I left it off. And then I go back, lie down, and I go, wait a minute, what if I didn't lock the door? So then I get back up, drive to work, try to unlock or lock the door. The door was locked, set on repeat. That's why I'm not an experimental chemist. I hate it. Okay, anyways. Rambling done for the day. No, it's more of just shutting your brain off at night. That's why I go home and I do stupid things like breaking rocks or not reading. Okay, so we have A and B. These are two different molecules. A and B together, some reactant or some change has occurred. What we're going to try to do is rationalize through the MOs the different charge transfer that's happening. So A, here is A's frontier MOs, HOMO, LUMO. B has a higher in energy HOMO and a higher in energy LUMO. Okay. What we're going to say happens, this is the result of some quantum chemical calculation or something that we know. The HOMO of A does nothing. It's not involved with the reaction, but where'd my blue go? The LUMO of A interacts with the HOMO of B. I'm being nondescript on their symmetry because we really don't care. Like if it's a sigma bond, that LUMO gotta still hang around. Okay, now electrons have to populate this thing, right? Following Hund's rule, gotta go here. Okay. So let's ask ourselves a couple of questions from this. What happens to the bond order between A and B? Yeah, it would be 1 right now. What happened to it? Increase, decrease remain the same. 0 to 1, so increase. Yeah. It increases. Which molecule behaves as a Lewis acid? A or B? What's the definition of a Lewis acid again? Mm-hmm. Yep.
So would it be A?
Mm-hmm. A. Why is it A? Yeah. Yep. It gained electrons. What does that make? Oh, then let's ask this question. Let's get more organic-y lingo.
Oh.
It's fine. The three types of acids and bases.
Mm-hmm. Yep, that's what it is. Which molecule is the nucleophile?
I wrote Jordan say the answer.
I mean, I guess, well, is it a good nucleophile or not? What is B's
What?
structure? Is it both?
Yeah, B's structure. Oh man, man, it's feeling like my thesis defense here. Draw the structure of B. What does B? Do it now. Your ideas are done. Go back again. Yeah. There's always resonance. Okay, so which molecule is a nucleophile? What does a nucleophile do?
It really likes.
Mm-hmm. Or a void of charge, right? Okay, it's the thing that behaves as the Lewis base, right?
Yeah.
So, what's our Lewis base in this case? Yeah, B.
Oh, A for acid, B for base.
It donates electron density. Next questions. Which molecule has gained electron density? There we go. Yeah, I know you're right, but I just hate it. It all looks goofy. That's why I wish, sometimes I wish we just had characters for words. I think I'd be a million times better that way. Yeah. Kanji, yeah. Dr. Ogawa says kanji sucks, though. So. It has no. Okay, so anyways, has gained electron density / charge. They're not exclusive, but I'm going to write it that way. So which molecule has gained charge? Yes. A. Okay. Let's try to rationalize this from a more molecular orbital mathematical approach on what's going on here. Am I okay to erase this side? Is it already?
Yes. Already through the thought.
That's just how it is, though, always.
We're going to call this, I always feel that about everything I teach. Like, I don't have enough time, go. Oh, that hurt. Pain in the neck. Okay. We're assuming some stuff here that might not be true. Like they might not be the same sign. There could be some other stuff that's included in there. Okay. These orbitals, or these MOs overlapped, right? Initially, this MO, if we were to draw out, let's do 1B. We'll call this CA prime. It's a little silly that I'm writing it this way. Because what would that MO look like? What would the value of CA be for this MO? Yeah. Because there is absolutely no contribution from A because this thing's on B. Now, what could you say about the value of CA in this new orbital? Is it 0? Yeah. It's got to contribute something.
Otherwise, there wouldn't be one.
Right. Now, this wave function, we'll call it, or this MO, now has some character on A. And it has to be populated at some point in time. Like, has to share some of that electron density. So what does that mean about the charge? Well, what entity gains charge? What entity loses charge? Yep, B has to lose charge because this orbital can only have 2 electrons in it. And now it went from having full character to less than full character. Meanwhile, this A orbital went from having no electrons, no character in respect to where those electrons were. Suddenly, now it has some character. So sometimes that electron density has to be around A. Does that make sense? Do you feel okay?